So, in the previous class, we discussed about the non-homogeneous ODE, and specifically the one with constant coefficient. Okay, so today we will discuss about the linear ODE, linear non-homogeneous ODE, specifically something related to something called the variation of parameters. So this is the last part of the second order ODE. So right after this we will start discussing about the higher order ODE. Right? When I say higher order, means third order, fourth order, or nth order, whatever we can consider. Okay, so here comes the non-homogeneous linear ODEs solution by variation of parameters. Too big. Okay, so let's first understand the concept clearly. So we understand what is the non-homogeneous linear ODE. And specifically we are discussing related to the second order. Of course, it can be extended to the multiple orders. Okay. So consider a second order linear non-homogeneous ODE with variable coefficients. Which one? Let's say this one is the ODE coefficients, variable coefficients. So one is the constant coefficients, another one is the variable of coefficients. Let's say y double dash plus px y dash plus qx y is equal to Rx. So if this is my ODE and I want to find out the solution to this ODE, and since this ODE, this Rx is not is equal to 0, that means I need to find out the solution for the non-homogeneous ODE. So as we discussed in the previous class, finding the solution of a ODE with non-homogeneous scenario, we have to find out two different solutions. What are those? So if you remember, if I mention YG stands for the general solution. So I need to find out YH plus YP. YH is the homogeneous solution and phi p is the particular solution. Right. So here, what is my YH? What is my YH? Yeah, C1 Y1 plus C2 Y2. That is what the standard homogeneous solution. But here is a trick for the particular solution. For the particular solution YP, YP will be treated as a similar method, but should be coming with U Y1 plus V Y2. So I added two terms here. One is called the U, another one is the V. So I will highlight this one, U and V. So here it was C1 and C2. C1 and C2 are the arbitrary constants. Here, in place of C1 and C2, I am putting two values, U and V in place of C1 and C2. So this U and V, these two are two what? Unknown functions. Two unknown functions whose value we need to determine. So in this method, we replace the arbitrary constants by two unknown functions, U and V. C1 and C2 are replaced by U and V. Now what is this U and V? It says, so if I will mention where U is equal to U is equal to minus Y2 R by W integration dx. That V is equal to Y1 into R by W integration dx. So if you look into these terms, something called R, which is given. That means we are talking about the same R here. That R, or I can mention this Rx specifically. Y1 and Y2 are the two bases. When we try to find out the homogeneous solution, we will have the C1 Y1 plus C2 Y2, that Y1 and Y2. Right. And what is W? What is W? We discussed possibly in the last week class, last Monday. What? Roxian. So that Roxian is, so I must mention where W is equal to Y1 Y2 dash minus Y2 Y1 dash, and it should be not is equal to 0. And this W stands for proxy. Right? Then if I will write the whole yp together, it should be like this. Yp is equal to minus y1 y2 r by w dx plus y2 y1 into r by w dx. Now the question arises how we come to this, because we find out these two values. This unknown function u is this one and this one. Right? This is what we are supposed to find out. But the question is, how do we find out this particular values? That we need to figure it out. Right? Okay. So basically it is the same idea we have studied before, how to get these values. The idea of getting u and v is substitution and reduction. I believe all of you remember the substitution and reduction method we discussed before. We have to follow the same method here. So let's assume yp is a solution. Okay? So step by step, let's follow. Yp is a solution of the ODE. Okay? And with, let's say, some condition. Let's assume yp is a solution to the problem or to the ODE in some condition. What is that yp? Let's assume yp is nothing but u y1 plus v y2, where u and v are two unknown functions. So if y2, yp is a solution, if we consider yp, this is yp, find out yp dash. What is yp dash? Just find out the derivative of yp dash. What is that? U dash y1 plus u y1 dash plus v dash y2 plus v y2 dash. Right. Now, I mentioned here some condition. So for this function u and v, we need two conditions. For the two function u and v, we need two conditions. What are those? Condition number one, yp must satisfy the OD. Which one? Y dash plus px, y double dash plus px y dash plus qx y is equal to rx. So it must satisfy this OD. Okay. And second condition is consider u dash y1 plus v dash y2 is equal to 0. Right. As I mentioned in the beginning, that yp is a solution of the ODE with some condition. You see, I mentioned here with some condition, right? So for yp to be the solution of the ODE, or to satisfy the solution to the ODE, one of the important condition is this one. We are assuming this one. We are considering this value. Why? I must mention here to satisfy the first condition, we consider the second condition. So this condition we are considering to satisfy the first one. Without that we cannot get it. So that is why we are considering this condition. Are you getting me? Or any confusion? Yes? Yeah, please review whatever we have written. If you are still confused, we cannot proceed. The concept need to be clarified, clear. So this one, I mean, YP is a solution to that one, and for that particular YP has to be a condition. YP is a solution to the ODE, so we need this condition. This is what we are assuming. Great. Okay. Let's move on. So, if the second condition is this, then tell me what is my YP? Sorry, what is my YP dash? Now, YP dash is equal to how much? Y1 dash plus V Y2 dash, can I write like this? Because U dash Y1 plus V dash Y2 is 0. That is what we are assuming. Right? Okay. Now, this is my YP dash. So, find out YP double dash. Find out YP double dash. If I will determine the YP double dash, it is going to be U dash Y1 dash plus U Y1 double dash plus V dash Y2 dash plus V Y2 double dash. Okay. The next step, so we have YP dash and YP double dash. So put these values in the original problem, OD. Okay, so put the values of YP double dash, YP dash and YP in the OD. Right? Okay. So put and find out. So if I will put for Y2, so what is the OD? Y double dash plus PX y dash plus qx y is equal to rx, and if I will put here, this is going to be u dash y1 dash plus u y1 double dash plus v dash y2 dash plus v y2 double dash. So this is for y double dash. Then the next one is qx qx, oh sorry, px, px u y1 dash plus v y2 dash plus qx, and what is y? U y1 plus v y2. I believe I have written everything correctly, and the final rx. So the next step is open this parenthesis, brackets, and try to collect the terms related to u together, v together, and others. So if I do that, I will get something like this: u into y1 dash, so y1 double dash plus p y1 dash plus q y1 plus p y2 double dash plus p y2 dash plus q y2, and finally plus u dash y1 dash plus v dash y2 dash is equal to r. Right? Right? Or anything wrong is it? So what is the value of this one? And what is the value of this one? In the homogeneous context, if y1 is a solution and y2 is a solution, what is the value of this one? Yeah. Any problem? What happened? Tell me. What is this value? This one. Y1 is a solution. This one will be 0. Now, I am not talking about the what is that? Non-homogeneous context. From the homogeneous context, this value will be 0 as well as this value will be 0. Because y1 and y2 are the two bases of the homogeneous scenario. Right. So ultimately, what I get is this one. U dash y1 dash plus v dash y2 dash is equal to r. Yes. And what we have considered or assumed, u dash y1 plus v dash y2 is equal to 0. The condition, second condition we have assumed. Yes. Now you have two equations. Your job is to what step you need to follow to find out these values. Okay. So one term, there are two different forms. One is the U dash, another one is the V dash. This U dash, V dash, V dash. We have to make some arithmetic arrangement to eliminate one and keep the other one. Okay. So it should be like this. To eliminate V dash, what I can do, that I multiply okay, let me write out U dash Y1 dash plus V dash Y2 dash is equal to R. Another one is the U dash Y1 plus V dash Y2 is equal to 0. So what I am doing here, I am multiplying minus Y2, and here I am multiplying Y2 dash. So, if I will perform this two, it is going to be minus y2 u dash u1 dash minus y2 v dash y2 dash is equal to minus r y2, and this one will be y2 dash u dash y1 plus u dash y2 dash v dash y2 is equal to 0. Adding these two. So adding these two, I will get minus y2 u dash y1 dash plus y2 dash u dash y1 is equal to minus r y2. Yes, because these two terms will be cancelled with each other. This and this, if I will add. So if I take u dash common, it will be u dash into, so this term I am writing, this one, u dash is equal to y1 y2 dash minus y2 y1 dash is equal to minus r y2. That implies it is nothing but u dash into w. This term is w is equal to minus r y2, or I can say u dash is equal to minus r y2 by w, or simply u is equal to minus y2 into r by w into plus x. Right? So you need to follow the same method to find out to eliminate the u dash to get the value of v. So you can check what was the value of u. This one. We just need to follow the similar process to find out the value of v. Just for your information, it will shortly mention. To eliminate u dash. So what I need to do? U dash y1 dash plus v dash y2 dash is equal to r, and u dash y1 plus v dash y2 is equal to 0. And what I will do here, here I am multiplying y1, and here I am multiplying minus y1 dash. After multiplying, adding, performing the simple arithmetic operation, I will get V dash is equal to R y1 by W, and V will be y1 into R by W. So this is the whole process of finding this the variable of parameters. Right. I just gave you the detailed derivation or detailed process, how exactly we need to find out the EV. But your job is not that difficult. Your job is just to apply this method. You need to identify which method it is. You need to identify which particular method you have to apply to get the solution. Right. So basically, what exactly we studied, if I summarize in few lines, so this is your V. If I summarize it in few lines, we have a OD, y double dash plus Px y dash plus Qx y is equal to Rx. Of course, it will be second order OD. So we need to find out the solution, that is y is equal to yh plus yp. So yz I can say, or just y. So where my yh is equal to c1y1 plus c2y2, where c1 and c2 are the two constants, arbitrary constants, and y1 and y2 are the two solutions, or you can say the basis, right? But for yp, I have to follow the entire things what we exactly studied. That is minus y1 integration y2 into r by w dx plus y2 integration y1 r by w dx, where w is the Roxian, that is y1 into y2 dash minus y2 into y1 dash is not equal to 0. W cannot be 0. If it is 0, then we will not get any value. Okay, so this is the whole process. What exactly we studied last 1 hour. Indeed. Now, the next step is, let's apply it into some ODs, second order non-homogeneous OD, and figure it out whether it is working or not. Okay. So the question for you, solve the non-homogeneous OD by variation of pi. Okay. So here is the question for you. Y double dash plus y is equal to sec x. Yeah. We'll take a break. After the break, we will continue. By the way, we will have the quiz on Thursday. This Thursday we will have the quiz, just like before. So again, it should be multiple. Multiple choice question. You like open book or closed book? Which one you like? Closed book. Open book was difficult, but you guys have done good. Many of you have done good. Just because of the multiple choice question. Okay, so the reason I'm making it multiple choice question because this can be done first of the evaluation process. You can have the grades easily. So let's go with the multiple choice question. Okay, this time it's not like the theoretical question. It's just like I will give the question. Just need to solve it and write down the answer. Like small questions. 10 questions, okay, 10 questions, and it should cover all the chapters like second order OD, all, whatever we have, questions, and each question will carry equal marks. Okay, just simple, no theoretical, nothing. You just need to solve it and write down the solution. I mean, select the right solution, A, B, C, D, whatever. Okay. Yeah. Please inform your friends who are not present here. Okay. The same thing after the exam, maybe you can have exam, let's say 30 minutes or something. Then you can just stop and evaluate. Okay. You can do like that.
So still multiple questions. 10 questions, I want to choose the answer that is
So I don't get your question. Say it again.
So total have 10 questions up to the second overall.
Yeah, second order.
And the question is to solve the OD and
Yes.
choose the correct.
Yeah, choose the correct solution for each question. Yes. Yeah, you need to be present. Mansu. You need to be present on the first. Okay. Yeah, so let's come back to the solution part of this one. Yeah, how to solve this one? First thing, you should solve for the homogeneous solution. Great. Yeah. Please solve it, the homogeneous solution. So what are the steps you need to find out first? Homogeneous OD, then characteristic equation, then the homogeneous solution, and the two bases, as well as the Roxian. You have to calculate all of them. Then you can go for the particular solution. Yeah. Yeah. Is there anybody have anything for me to share? What is the homogeneous solution? What is the characteristic equation? Lambda. Lambda. Sit. Okay. That implies lambda is equal to plus minus I. Yeah. Then what is the characteristic equation? C1 cosine x plus C2 sin x. Very good. That means your y1 is equal to cosine x, y2 is equal to sin x. Oh. Yeah. Y1, y2, you got. What about your double? How much? 1. Right? So, can you find out what is the YP? Just need to put all the values. Y1, Y2, W. You have all the information. Just need to put them. Where your YP is equal to minus Y1 integration Y2 into R by W dx plus Y2 integration Y1 into R by W dx. Just need to put these values. right? You guys can do it, right? Anything is missing? Why some of you are quite surprised? Any issue? Or anything wrong? If you are okay, we can move for the next question. Why you guys are having a fight? You are not responding. Yes, no, nothing. Okay, so let's move on. Next question. Okay? Yes, no, nothing. Okay, next question. Y double dash minus 2y dash plus y is equal to e to the power x sin x. Hi. Yeah. You have anything for me? Please. Characteristic equation. Yes. This one. Okay. And homogeneous solution. Okay. So we can say y1 is equal to e to the power x, y2 equal to x e to the power x, right? What about the w? E to the power 2x, okay. And have you find out the yp? Minus e to the power x sin x. Are you getting the same? So if this, then yt is c1 plus c2x e to the power x minus e to the power x sin x. This will be your final solution. Okay, so finally we have the overall idea about the second order ODE. So here we will stop the second order and move for the higher order ODE. So since there will be few times left, I will start the basic concept of higher order ODE and we will study the detail in the next class. Okay. Just give me a minute. You want the previous slide? Previous one? Are you saying something to me? No? Okay. Okay, so now let's focus on higher order ODE. Maybe we just need one or two plus because what we have studied for second order and first order, it is just the extension of that one. Okay, and then after that we will move to the final part of the course, that is the Laplace. Okay, so here is the higher order linear ODEs. So which one is the higher order ODE? So basically I can say an ODE of nth order. So the written in this.
So this thing,
Oh. Nth order is in this way. It is x, y, y dash, y double dash, and so on. Can go up to yn. I can put like this. That means the nth order is equal to 0. Where yn stands for d to the power n y by dx to the power n. Right? And a linear ODE is in the form y to the yn plus pn minus 1 x yn minus 1 plus pn minus 2 x yn minus 2 and so on. We can go to p1x into y dash plus p0x into y is equal to rx. This is the generalized any ODE you can see. In general, this is the ODE, nth order ODE. So here in this one, let us say this one is, if I mention this one is equation 1 or something like that. Okay, this equation 1, let us say. So if here n is equal to 1, then we say it is first order. If n is equal to 2, it is second order. Then after the second order, n is equal to 3, n is equal to 4, whatever you can go up to, n is equal to all the nth order. So all these things are considered in the category of higher order So in this equation, I just show you this equation 1. In this equation 1, okay, P1, P2, P3 up to Pn minus 1 are okay. So in this equation, again, the concept is pretty much same. If Rx is equal to 0 in equation 1, then the ODE is homogeneous. Else non-homogeneous. Okay. Now in case of homogeneous ODE, we can write the ODEs in this form, yn plus Pn minus 1 y to the power n minus 1, n minus 1 derivative plus P n minus 2 into y n minus 2 and so on. We can go up to P1 y dash plus P0 y is equal to 0. This is the homogeneous. The general solution to this ODE is y is equal to C1 y1 plus C2 y2 and so on to Cn yn. Right? Where C1, C2 up to Cn are arbitrary constants y1, y2 up to yn are bases. And just like all the ODE case, we need to find out the specific value of this constant C1, C2, C3 to find out the particular solution. In a particular solution, we need to obtain specific values of C1, C2 up to C. So this is the basic concept or the idea of higher order ODE. Okay. And one more thing I must tell you, in the higher order ODE, for initial value problem, okay, for initial value problem, we need n initial conditions for the nth order ODE with given x value, that means you can say x is equal to xj. That means something like this: y x0 is equal to, let's say, k0, y dash x0 is equal to maybe k1, and so on. You can have y to the power of yn minus 1 derivative x0 is equal to, so let's say, k n minus 1, something like this must be given to determine the constants C1, C2, C3, etc. Okay, so in the next class we will discuss in detail all possible cases of higher order. And we will try to finish it up so that we can directly move to the other one. Okay. So we will discuss this one in next Monday, and on Thursday we will have the quiz. Okay. Thank you very much. You guys okay, open source, that's fine. Yeah, you can use calculator.